Alright, DICOM data types. Data comes in many shapes and sizes. Patient names are alpha, meaning it uses alphabet characters. Right? Names are all in letters. Addresses are alphanumeric. They're a mix of letters and numbers. Image measurements are in millimeters. So we have all these different types of data. DICOM uses 27 data types called value representations, or VRs, to encode the data. Each VR has a 2-letter code that denotes what it is. So here's 5 important VRs. There are lots and lots. There's probably hundreds of VRs. Let's just start with 5 basic VRs to give you the idea. AE, application entity. PN, person name. DA is date. TM is time. DT equals date time. So an application entity VR type. It's a string of characters that identifies a device. For example, at Hack General Hospital, we might have Hack General Hospital CT1 or HGCT1. For the MR unit, we might have Hack General Hospital MR1 or HGMR1, Ultrasound 1, things like that. So every modality has an application entity or a name that identifies it on a DICOM network. So really important, do not use the letter O or the number 0 in your AE titles. Never, ever do this. Okay? For example, mammo. If you type mammo 1 as an AE title, is that the letter O and the numeral 1? Or is it mam, numeral 0, number 1 in your AE title? It can get really confusing. And so application entity has a 16-character limit. You can't go beyond 16 characters when you're making an application entity name. Person name. Person name is simply a person's name. It's PN, and it's separated by carets. And the carets count as characters. So this has a 64-character limit. You can come up against that limit in Hawaii. And so just remember to count the carets as characters. They count in that character limit. Date. The date is in this format. YY, MM, DD, or the year, followed by the month, and then the day. Right? So 2016, April 1st would be 2016-0401. Right? Now, here's the fun thing. DICOM puts the year, then the month, then the day. HL7 doesn't do it the same way. So DICOM and HL7 can use different formats. And I know I've wandered off into the HL7 course here, but I just want you to know that the way the date is written in HL7 can be many different ways. DICOM is always in this format. So did you guess the character limit for this data type? Yes, it's an 8-character limit because you should only have 8 characters for the date. Time. Time is in this format. Hour, hour, minute, minute, second, second, and then AM or PM. So 1832.00 would be 6:32 PM. That is the time format. And it has a 16-character limit. Date time. This is the date time together in one format. And it uses the same individual formats, just all stuck together. So you have the year, the month, the day, the hour, the minute, the second, the AM, PM code, and then ZZXX is the time zone code. If you've ever looked at the time zones, like maybe when you set them on your computer, you'll see that every time zone not only has a name, but it also has an associated number. So 0500 indicates the central time zone. And this has a 26-character limit. So VR length. VR length has an important reason. How do you know where a sentence ends? Because it's got a question mark right there, right? We know where a sentence ends in a written statement because we always end it with punctuation. So DICOM defines the endpoint by setting a value for the length of the data strings. That's why you have these character limits so that it knows where that chunk of data ends. DICOM uses even length, meaning the string must always be an even number of elements. Even if the data is text and an odd number, it will add a space to the end. For example, Joe Smith. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. 9 is not an even number. So how DICOM would express that would be Joe, Smith, with an extra space at the end, giving it an even length of 10. If it's in binary format, it adds a null value at the end of the string, right? So if it's using bytes, right? Instead of using text, if it was 9 bytes, it would just simply add an extra byte at the end like that of all zeros so that it would stay even length. Data length can be fixed or limited. Example of a fixed data length is the year, month, day. It's always going to be 8. It's never going to be 7. It's never going to be 6. There's no range. It will always be 8. So it's fixed at 8 characters. Limited is a person name. It can be between 1 and 64. So it might be limited to 12 characters. However, it must be even length compliant, whether it's 12 or 14 or 16 or 10 or 8. It always has to be even length compliant. You cannot have a person's name be 9 characters long. It may be 9 letters long, but it can't be 9 characters long. And hopefully you understand the distinction between characters and letters. Unique identifiers, or UIDs. DICOM uses 2 types of unique identifiers. Locally unique is a unique identifier inside your network. Globally unique is a unique identifier anywhere in the world. An example of a locally unique identifier is the AE title of a modality. It needs to be unique inside your DICOM network. So at Hack General Hospital, we could have HGCT1, and at Harrisburg General Hospital, they could have HGCT1. We can use the same AE titles locally unique. No problems there. Example of a globally unique identifier is the study UID. Every study has a UID that identifies that particular instance of the study. If study moves from one AE to another AE, the receiving AE modifies the study UID to create a new instance of the study. In other words, if you sent a CT of the head from Pennsylvania to Australia in the middle of the night, that study would have one UID in your PACS system and a different UID in the PACS system in Australia. Okay, so that's not uncommon. When it's the middle of the night here and all the doctors at Lancaster General go home, the physicians in Australia are just waking up. So we do send studies from Lancaster General to Australia to be read overnight where it's the middle of the day, and then they send those reports back. So that's not something crazy just to demonstrate the idea of a globally unique UID. That really happens. And so it's important to understand that that UID is unique everywhere it goes. It's the only UID in the world that identifies that particular instance of that particular study, right? So one instance exists in the Lancaster General PACS system, and another instance of the same study exists in the Australia PACS system. Same study, if you looked at the pictures, they would appear identical, but one UID identifies it as being in Lancaster, the other UID has data that identifies it as being in Australia. So that is a globally unique identifier. Wow. Hopefully I didn't melt your brains with all that, and let me know if you have any questions. Thanks for watching.